Hi, my name is Andrew Larsen, and together with my teammates Andrew Magia and Brian Gauthier, we have put together an analytic report for the CEO of Budweiser to take a look at beers and breweries throughout the United States. Two data sets were used for this analysis, the beers and the breweries data set. The beers data set contains things like ABV and IBU for each beer, while breweries contains things like location for each of the breweries that these beers come from. These data sets were merged, resulting in 2,410 total observations. There are two columns that do contain NA values, the ABV and the IBU columns. Whenever we do an analysis using ABV or IBU, we remove those rows from the analysis. Getting to breweries by state, you can see that there are 558 breweries across all states. Colorado has the largest breweries with 47. 25% of breweries are within 4 states. These are Colorado, California, Michigan, and Oregon. And 50% of all breweries are actually within 9 states, as noted in the top chart. Looking at the Pareto analysis in the bottom of this page, you can see that there's a concentration of breweries in a few states, while as you get further to the right, those states don't have as many breweries. Taking a look at ABV by state, you can see that median ABV, is pretty consistent over each state. Each state has between a 0.5 and a 0.6 median ABV, while there are some outliers in New Jersey and Utah. Maximum ABV does have a few outliers above 10% ABV, but for the most part, most states have a maximum beer ABV of 10%. As you can see on this map, most states have a maximum of 10%, but Colorado, Indiana, and Kentucky are circled here, indicating that they do have an ABV higher than 10%. The IBU by state is much more varied. As you can see, the median IBU ranges from 20 IBUs to 60 IBUs, while the maximum beer IBU by state maxes out at 138. On this map, you can see that Oregon is circled. Oregon is known for having a beer with a lot of hops. The rest of the states tend to be on the coasts. The outliers here are Indiana, Ohio, and Minnesota. Indiana and Ohio are close enough to the concentration in the Northeast that makes sense. Minnesota is most certainly an outlier here, though. Distribution of ABV, you can see that ABV is pretty normal. It has a slight right skew. There aren't a lot of beers with a lower than 4% ABV, but there are definitely quite a few beers with above a 7% ABV, which is why you see that right skew. You can see that there's a minimum ABV beer of 0.1%. This would be considered a non-alcoholic beer. So is there a relationship between ABV and IBU? There does seem to be a positive correlation between the two variables. As ABV goes up, IBU tends to go up, and as IBU goes up, ABV tends to go up. This correlation is 0.671, which indicates a moderate to high correlation between the two variables. We did run a statistical test and confirmed that the p-value is below 0.05, so this is a statistically significant correlation. Now we moved on to classification. We're trying to use the ABV and IBU variables in order to classify beers as either an ale or an IPA using KN and a naive Bayes, but first we did a little bit of exploratory data analysis. The ABV variable does seem to have a higher, the IPAs tend to have a higher ABV and IBU than the ales and other beers, as you can see here. The KNN classification based on ABV and IBU, we had a KNN with a K equals 5 classifier, as you can see in that top left chart. K equals 5 does seem to have the highest accuracy. When we classified beers, it does seem to have an 83% accuracy, which is pretty good, but we're wondering how the KNN stacks up against naive Bayes, which you can see here. Here, a naive Bayes classifier has an accuracy of 86%. So while the naive Bayes was better than the KNN, we do recommend the naive Bayes over the KNN for classifying ales and IPAs using the ABV and IBU variables. So we did find something pretty interesting in the data. We wanted to run a two-way analysis of variance in order to check if regions of the United States have an effect on ABV and IBU, and whether beer size has a has a statistically significant effect on ABV and IBU. We were wondering if there was an interaction between these two variables, which means that 12 and 16 ounce beers will have a different ABV and IBU for each region. That is a greater difference in the Northeast for 12 versus 16 compared to the Midwest. Looking at these graphs here, you can see that for the most part, 16 ounce beers have a higher ABV than the 12 ounce counterparts, but there doesn't seem to be a dependence on region about how much that difference is. Similarly, you can see on the IBU variable that there is a higher IBU for a 16 ounce can, but the difference in each region is about the same. So when we ran the 2A ANOVA, this seemed to confirm this. There was no interaction term. Ounce is a significant factor in both ABV and IBU. And there is some evidence that region is a factor in ABV, although the p-value is only 0.058, I believe. So it is slightly above that 0.05 threshold, but not by much. Both ounces and region are significant factors in determining IBU, meaning that they have p-values less than 0.05. The differences in ABV occur in the Northeast and Midwest regions and the ounces of beer. No other difference occurs in any region. The differences occur in the Midwest regions in IBU and ounces in the beer as well. So if you were marketing a high ABV and IBU beer, I would recommend doing that in a 16-ounce can. And if you are marketing a high IBU beer, I would recommend doing that in the West. High ABV beer, I recommend to do in the Northeast. Please let me know if you have any questions, and thank you for attending.